Good evening, ladies and gentlemen, and welcome to the first session of LIT webinar series. I would like also to welcome our guest today, which only few people exhibit as much passion for the downstream industry as him. His passion to the industry helped him create successful business model. One well-known model is the three-pentagon model, which provides refining and petrochemical industries with a roadmap for their improvement plans and investment options. He backs in over 46 years of sector experience, along with numerous qualifications, patents, and technical papers. During his career, he has worked through the major challenges faced by the refining industry. Our guest started his journey with IFP. After that, he moved to BB Amoco, followed by UOB, and then he joined Shell in 2006 to lead its new worldwide hydroprocessing licensing organization. Such was its success, his portfolio was later extended to include all of Shell's licensed refinery and petrochemical technologies. And in 2009, he was appointed vice president and continued in his position till his retirement in June 2018. So please join me to welcome Mr. Suleyman Ozmen. Mr. Suleyman, we are so glad to have you in this session today. And just before you start, I think Dr. Bassem from KFUPM would like also to welcome you. Dr. Bassem.
Thank you very much, Ali, for the nice introduction to such a big name, Mr. Suleyman. Just for those who don't know, we have started the student program back in 2013 during MEPIC in Bahrain. Then in 2015, we had another session as a student program, which later become as youth program, and it is always organized by the YPC from Saudi Arabia, the chapter from KFUPM, and BChemE from Bahrain. And in addition to this, in MEPIC, we had started also the student program or youth program during the GDA, started with BChemE, and it was really successful. In all those programs, the name that you will see always as a helpful to our youth is Mr. Suleyman. We never hear no from him whenever we ask him for a help, for a presentation, for anything with our student or our youth. So I really thank him very well, and I want to just say that we cannot thank him enough. So please, Mr. Suleyman, it's all yours.
Thank you, Dr. Basim. Thank you, Ali, for the nice welcome. I'm honored to speak today to the future talents and their professors, the future leaders, the passionate, experienced academicians and colleagues. Not only we have the people who are going to join the industry, who have joined, but they are in the audience. There are many people with a lot of experience that have shared the passion that I had for this industry. I would like to thanks King Fahd University of Petroleum Mineral, American Institute of Chemical Engineers Association, and then BChemE. I've been associated with you guys for many years with love. I did all the sessions with you, and hopefully in the next 1 hour, I'm going to share with you my experience in the industry, which is a 46 years journey. I'm just asking Ali, can you hear me? Everything is okay?
Yes, Suleyman, everything is okay. You can go ahead. The floor is yours.
I'm now going to, as you can see on the picture, there's Dr. Basim and myself in MEPEC event in last November. And it's a nice souvenir I have as a picture I wanted to put in the slide. Today, my goal is there are 3 outline messages to young engineers and future leaders that I would like to do. The first one is, I want you to understand how and why refining industry will continue to evolve. There's always improvements and there's always challenges, and we need engineers, talents to resolve the challenge we have in the future. The second one is we need to be ready for the market demand changes. How we do that is by developing, commercializing, adopting new technology. Technologies can be process, can be catalyst, can be hardware, equipment, can be digitalization, etc. Everyone contributes to the improvements we see in the refining industry. At the same time, we might need to make the refining industry competitive while meeting the environmental regulation, its product specifications, its emission reduction, including CO2. And the third one I want you to learn from this session is that we need to develop competent and passionate talents to lead the next evolution journey with new improved technology and its efficient implementation. Without the talents, technology cannot be delivered. Then we need engineers, researchers to develop, but we need also talent to implement and all that. Then the three things is why, what is the market needing, and the talents we need. When we go through this journey, and I will show this slide again at the end and ask you a question if you agree on this. For the agenda, I'm going to go to the historical, recent, and future evolution, tell you what happened in the last 46 years and what should be happen. To ask the question, can we deliver the new wave of evolution? Then I will show you some short and long-term market trends and requirement changes that are happening in our industry. Then I will also talk about downstream business options to deliver strong financial returns, because we are not building refineries not to make money. We are there to be a profitable business there, and we need to adapt to the market. Then I will talk to you about some example of technology, and there are many of them that needs to be innovated and to be commercialized. Talk a little bit some additional challenges, and then make a recommendation which is valid to the entire industry. To deliver the continuous evolution, there are three things we need to do. One is to identify the short, long-term market trends, environmental regulation to be imposed, and economical challenge. The question is what is the future? Then set the downstream business objective and strategy, knowing what the future is looking. And then, of course, develop and acquire the innovative technology and speed up its commercialization and implementation. On the picture I show in the bottom, you can see on the left is today. You need to understand where are we today. Needs to define the future. First, understand what the future, and you can also define the future. You can be a leader defining the future. To go that, you need to do the strategic imperatives. Is it technology? Is it restructuring? Is it talents? And when I say restructuring is, does a refinery operate only to make petrochemicals, or is it a combination of transportation fuel and petrochemicals? And think about how you want to run the refinery in the future in order to meet the objective of the future, and then what kind of talents we need in order to deliver this. Historical evolution. If I start looking to my graduation year, 1974, many of you were not born. At that year, the oil price tripled 1 year over 10 US dollar. This was the first shock into the industry. Suddenly, oil price, who has been stable at $2-3 for many years, has gone to $10. Of course, I will not speak about the shock 2 days ago where we are paying people to take crude oil, but this is just a little glitch. Then at that time, and myself, we start working on alternative fuels. We said, is hydrogen the next one? In fact, if you go and Google my name and hydrogen, you will find I wrote a paper in 1976 about hydrogen energy. Then we took the idea of looking to methanol. The coal was available, natural gas was available. Is methanol another alternative fuel? We looked to coal gasification, liquefaction, and also nuclear power. Remember, France started building more and more nuclear power in order to produce electricity rather than using fuel oil. Then, of course, came the idea of lowering car mileage, smaller cars. When I came to the US, my first car used to do 11 miles per gallon. Today, my car does 25 miles per gallon. Using diesel fuel was also, for better mileage, became very popular. Then in order to produce gasoline with high octane and unleaded gasoline, we needed to have technologies. Then there are licensors who developed technology called CCR platformer. We went in isomerization. We went into advanced FCC technology, and alkylation became very popular. All these in order to produce more gasoline, and especially unleaded gasoline and high octane. Then came the period of oxygenate. We believe that if we put oxygen in the gasoline, there will be less CO emission out of the cars. Then we want to transform everything, all the COs out to CO2. Then came the period of MTB, ETB. I worked on that for many years. Then methanol again. Then renewable ethanol, where agricultural products were used in order to produce ethanol in US, the E15 and E85. Then came the period where we wanted to lower sulfur aromatics in gasoline in a higher octane, diesel higher cetane, and clean fuels, and trend toward diesel fuels in cars. Then there was this period where we wanted to have very clean, very reliable, very high efficiency transportation fuel, either gasoline or diesel. Then technologies were improved, catalysts were developed on desulfurization, hydrocracking became very popular, etc. Then this period, what I call the H period, is where more and cleaner transportation fuel is needed. This is period 1. Comes period 2, which is the recent, where it's less and cleaner fuel oil and chemical and crude oil to chemicals. Then increase margin by upgrading difficult crude and lower fuel oil production. You will hear the word BOB, or bottom of the barrel. The idea will be, if there is no need for fuel oil because the fuel oil market has been taken by, let's say, by natural gas, then you can go to a refinery with total conversion to zero fuels. Then also, if you have a power plant and you want lower sulfur in your fuel oil, resid hydrotreating became very popular. Then the hydrocracking became also very popular, vacuum gas oil hydrotreater, but then the asphalted oil hydrocracker. Then came the period a few years ago, the resid hydrocracking, ebulliting bed or slurry. Many licensors have this technology to reduce resid while either making maximum naphtha or middle distillate production. Naphtha can go to petrochemical, and middle distillate, of course, can go for transportation diesel. Then came a very old technology, both of them old but very popular these days, coker and solvent deasphalting technology. Then cleaner fuel oil, the journey continues with IMO 2020. As you know, transportation marine fuel had to come up with a new spec of 0.5% sulfur fuel oil. That put a challenge in the refining industry. We needed now high conversion resid hydrocracker, resid hydrotreater, either fixed bed or ebulliting bed. Then at the same time, there were demand for new generation biofuels renewables. Many countries have imposed that the transportation fuel has to have a certain percentage of renewables. Then in all technology alkylation, remember alkylation was either sulfuric acid or HF. Then came the people who have innovating technology, the catalytic alkylation, which several licensors have made it available now, and it's been commercialized. Then countries who have access to coal, like China, went to the new, what I call the new routes to petrochemicals. It's not new, but became more popular, where let's say you go from coal to methanol, from methanol to olefin. And the MTO technology that I was involved in developing in the early 90s now became very popular because of the availability of methanol with either cheap natural gas or availability of coal. Then this period R is less and cleaner fuel oil. Now we went to the second period. Now what's the future? What is the next period? If we look, we have to accept the fact that the fuel oil is going to be reduced. The availability of either natural gas, liquefied natural gas, hydrogen, biofuels, there are many alternatives to replace fuel oil. Demand in petrochemical is growing faster than the demand in transportation fuels. The need for synthetic fibers, advanced polymers, packaging, pharmaceutical, automotive. Transportation fuel demand could peak mid-2030 with increased share of electrical vehicles. As you know, electrical vehicles has become very popular. It's going to increase step by step, which means it's going to give a challenge to the refineries when the demand will peak. Then there are many options on crude oil. There is tight oil yielding better feedstock for petrochemical. We have cheap shale oil, especially in the US. And then lighter crude for direct crude oil to chemicals. As you know, crude oil to chemicals, there's different routes to do, but one of them you can put in an FCC type reactor, light crude, and prepare feedstock for petrochemicals. Future evolution. This is now a completely out of my zone era. This is your era. I'm retired. I'm sitting here only telling the story of the past, but the future is real. First, refinery, petrochemical integration. There is already in the books many mega projects. The cost is around $10 to $20 billion to build those projects. Very popular in China. It's either the crude oil to chemicals route is either direct, like hydrocracking of light crude, or FCC, or steam cracking, or through the refining route. You will see a lot of paper, a lot of presentation on COTC. And in Saudi Arabia, Aramco and SABIC together have a plan to build a big project on this route. Then integrated refining, converting their crude to petrochemical. If you look to the projects that has been built recently or are in the books, we see that 30 to 50% of the crude has been converted to petrochemicals. There's even schemes that show that you can go up to 80% converting crude to petrochemicals. Then that's going to be the next era. Refining will be really totally integrated with petrochemical. Oh, hold a minute. Okay, here. Then you will hear something called, and you need to do a lot of search and ask your professors to tell you more about that, toward what I call a zero net carbon refinery with carbon rejection and hydrogen addition, energy efficiency, fuel substitution to methane, green heat, power, concentrated power or green power, carbon capture. Refineries are going to be completely changed in the future in order to be more of a zero net carbon refinery. Imagine using solar panels in refineries to produce electricity to turn all your equipment, and it's coming, especially the control systems. Now, something which is again very popular is the new refineries and upgrade refineries to be digitally connected. Digitalization is becoming extremely important for process optimization, reliability, minimize emission utility consumption, eliminate waste, helping lack of experience staff. In the audience, I know there are several of young colleagues in the industry who are from Honeywell, and this is really something they are passionate about. And then there will be many technology will be needed to produce low carbon liquid with the potential to deliver low emission mobility across life cycle in an all transport segment, such as sustainable biofuels, CCS, CCU, renewable hydrogen, and power to liquid. This is now suddenly the refineries are going to be different. The fuels that we'll be using will be different. And this is the period, the future evolution, COTC, zero net carbon refinery, and low emission mobility. And there is a tremendous challenge. We need talents, we need engineers, we need leaders to bring us to the next future evolution. This is for my grandchildren period. Now, the question is, can we deliver all this? Yes. Each time we had a challenge, I found over my 46 years, the technology supplier developers, they always come up with a solution. Is it coming from a licensor? Is it coming from universities? Does it come from an engineering company? Is it through some consultancy ideas? But it's going to happen. One recommendation I have, be an early adopter of no technology. Can we be a risk taker? We are a conservative industry, but these days there are options to adopt new technology and be the first risk taker. When the first high conversion ebulliting bed hydrocracker were put on stream, someone had to take the risk. So the first one who wanted to do the HF alkylation, not the catalytic alkylation, had to take the risk. It's very important. And more you are experienced, more you have good people around you to advise you, you will be able to take risks. Operator needs to work closely with technology innovator. There are companies who are called the technology innovator. They are also the operating companies. There are sometimes operating companies that does both. Like you take Aramco, you take ADNOC, you take Shell, you take Mobil Oil. They do their own research to innovate. We can always find solution. I'm very hopeful that in the future, when we understand what the challenges are, there will be always a solution. Let's go, and I might be sometimes repeating myself, example short-term market trends that we need to recognize. The IMO, the zero fuel refinery, is the reality. Don't build a refinery that makes 30% fuel oil. Grow in petrochemical. We need more feedstock for petrochemical, but don't overbuild. Need for biofuels renewable, but without need for subsidy. Many biofuels these days are subsidized. They are tax incentive to go, but the reality is at a certain point they have to become as competitive as the crude route. There will be a change in ratio of gasoline diesel to vehicle electrification. The gasoline might go down, the diesel might stabilize, also go down, but you need to understand what's going to be the ratio of gasoline diesel in the future. There is shortage of propylene, for example, in the industry. Refineries are a nice way of producing propylene from FCCs, or you can have individual propane dehydrogenation technology to produce propylene. Implement emission management, energy optimization, CO2 reduction. You will see many papers, many presentations, many ideas on this field. Increase digital transformation, increase reliability, alternative routes, including bioengineering, where different ways of producing chemicals are being very popular. One of the companies called Genomatics in the US. And the reason I know my colleague works there. Now, downstream options to deliver strong financial. First of all, when you go into a project that your company is going to spend $5 to $20 billion, make sure to choose the right configuration and complexity. You are there to convert the molecules to make money at the end of the day and recognizing the market cycle. Be an early adapter. We talked about that. This is the technology. There's a 3-pentagon model. You are welcome to go in the internet and find it, or ask me to send you any paper on this. It's where a refinery is not only to build new units, but is also improve operations and also revamp. There are 3 ways. Either you improve operations, or you revamp, or you add new units. It's called the 3-pentagon model. Implement petrochemical integration. We talked about that. Choose the right location. Location is, of course, very important. Are you near the market? Do you have a port? Is available the feedstock? And the right JV partner. I have written a lot of documents on what's the best JV partners to have. Not a company that looks exactly like you, but someone who is complementing is the way to go. Select the right capacity. Don't build a refinery of 20,000 barrels a day these days. It has to be over 300,000 barrels and a complexity at least of 10 and even more. Adapt to the profile of the new owners. Sometimes, especially in the West, you will see that refineries are being acquired by traders or JV owners, or national oil company versus international oil companies, or individual refineries. You have individual refineries very successful in the US, like Valero, who went and bought close to 15 old refineries and make them very profitable. This is key. Deliver projects on schedule, within budget, and ready to the new market. When you decide what the new market looks like, think about it twice, do your studies well, but once you decide which configuration you are adopting, make sure you do deliver the project on schedule. Do you know that a refinery in China recently called, it starts with an H, suddenly I forget the name, delivered a new refinery project in 26 months. I know many projects in the world that has delivered the same project in 10 to 12 years. Deliver projects on time. Access to resource engineers, operators. We need skills. You need skills, especially on new technologies. That's why you, the talents coming out of the university, people who have just joined the industry, we need you. We need you to become very good to adapt to these new changes. And then consider long-term plan and strategy, knowing that the refinery will be, remember, when you build a refinery, this refinery will have a life of 40, 50, 60 years sometimes. And if you go to the studies done by a Solomon company, a very famous consultant, where they interview each refineries, and the average age of best refinery is 26 years, which means there are refineries who are 26 years old who are the best refineries in the world because they run it well, they have the right conversion, they are reliable. There are many good things that they have those refineries. Then remember, when you build a refinery, this is not like your car that is 4 or 5 years life. This is going to have 40 years. But over time, you will improve it. Over time, you will add new units. I know many refineries who have started on hydroskimming refinery who have added FCC, hydrocracker, and more conversions. Now, example of technologies that where we are seeing more and more development, the simple ones, using FCC to produce olefins, or high conversion resid hydrocracking, solid bed ionic liquid alkylation to eliminate the need for HF and sulfuric acid, efficient advanced distillation and separation. Don't underestimate the importance of distillation. Every process unit, most of the process units that you are having have a distillation, and a good, effective, advanced distillation will make your process even more better. Digitalisation, extremely important. CO2 capture, very important. Economic biofuels technology, very important. Effective emission management. New material for catalyst production. These days, the catalyst manufacturer and developer are looking for new materials. There is one being developed by a company called Rive, which was purchased by another company, but initially Shell and Aramco was a big investor in this company. But there are new materials, zeolitical materials, all kind of materials that will be developed to make your kettles even better. There's also the ideas of gasification of waste and reuse of recycled single-use plastic to produce syngas. Remember, recycling is going to be very important. The world cannot afford to have a seventh continent full of used plastic. The reason I'm saying the seventh continent, there was a big event in Turkey, in Istanbul, called the seventh continent, and the seventh continent was around the pollution created by all of us throwing our plastics, single-use plastics. That's going to change. Technology with lower carbon footprint needs to be developed, and solar energy in refining. Then my list is short, not on the screen. On the screen it's very big, but in short, because there's more and more. It's you, the next generation, is going to make this list larger and deliver it. Okay. Next challenge, additional challenges. Market might not be clear potential dislocation. Many times, let's say that today you are thinking about a certain configuration of your refinery. Let's say that the owners, the investors will decide in 1.5 year to do the kickoff meeting with a licensor. Then the project takes 8-9 years to be implemented versus the Chinese model, which is 3 years. Let's say average 5 years, which means now in 7 years, are you sure that the market is the same market you have estimated? We have seen that many projects, when they are put on stream, doesn't match the market. There's a small percentage who are missing the market, and it's a big challenge. You need a lot of good consultants, help, engineers to define what will be the market, looking to the historical and looking for the reality. Project value are difficult to predict. I have seen issues, for example, with diesel. Diesel that we thought was going to a certain value, the value has changed. Product value can change. Predicting that is going to be also a challenge. Overcapacity. If today everyone builds up crude oil to chemicals, there will be overcapacity. I've seen many years ago on paraxylene when a big investor came and decided to produce a large amount of paraxylene. Before he invested, the paraxylene price per metric ton was around 1,000 ton. When he came on stream, it was $450 per metric ton because of overcapacity. Reduction of SOx and OX, reduce CO2, operate in a CO2 constrained world, flat diesel market, electrical cars, reality, we talked about that, disposable of petrochemical products, reduce air pollutant, selection of availability type of crude, ever-changing specification regulations. Regulation change, usually they give you 2-3 years before a legislation come on changes. Project implementation and delivery delays. That is the one that I usually get very upset when I see all this effort made by teams to kick off a project and projects are delayed. This is not acceptable. Then don't go into a project if you're going to delay and make it so many years. But this is something I'm a little bit passionate about. Now, here's my list of recommendations to the industry, to the young and to the seasoned engineers. Start consulting technology providers early, few years before investing is decided. Consider investing in new technology development. There will be a period before what I call a licensor kickoff meeting is to do your homework. Engage with them. Go and visit the plants they have built. Go and see their labs. Talk to their scientists. But be very comfortable with the technology. Make sure to understand mid and long-term trends. What are the environmental regulations that the regulator will start imposing on you? What's the competition, local production, product export threat? Geopolitical trends. Do you want to produce everything in-house or you want to rely on the international trading? New energy supply consumer, electrical cars, biofuels, fuels oil for power supply. All these things you need to really understand, and that's where you have economists, consultants to help you. Deliver project on time, on budget with proper management. That's the famous story I gave you, 26 months versus 120 months. Be careful on potential overcapacity in petrochemical, as we mentioned that before. Choose the right digitalization program. While there is a group of people in your team who are going to focus on selecting technology, selecting the feed contractor, selecting the EPC, make sure you understand the right digitalization program. Go and visit plants where new equipment has been put. Go and talk to Honeywell and others. What is the most popular? Because you will see a lot of benefits going fully digitalized. Consider producing refining specialty. Lubes, winter diesel. I had one refinery in Ukraine who made a lot of money because they were producing winter diesel. They were unique in the market there. Or high octane gasoline. This is where in Germany those Porsche needs high octane gasoline. Or low sulfur fuel oil. But consider having your refinery with some specialty product that matches your market, your demand. Evaluate key options. Is there residue upgrading, zero fuel, petrochemical, refining specialty? But that's when comes the time to do the right evaluation for your configuration. Be ready to adopt technology to reduce CO2 emissions and produce low carbon fuel. This is going to be serious stuff. This is where a lot of effort has to be put. CO2 emission reduction and produce low carbon fuels. Now I went to my presentation, and now let's go back to the 3 outline messages. I hope you understand how and why refining industry will continue to evolve. You have seen we have done it, we are doing it, and we are going to do in the future. The other one is we need to be ready for market demand. Technology has to be there. The refiner has to be competitive. I hope you understand this is very important. I hope also that we need talents. We need competent and passionate talents to lead the next evolution journey with new improved technology and its efficient implementation. And my last message, and we're going to do a poll on that, are you ready to embark in this journey? And you want to learn more, and I hope you want to learn more. And if during this presentation there is specific items that you want to learn more, reach your professors, reach your colleagues, reach the licensor, or come to me through LinkedIn and ask me the question. I will guide you to the right way. And I wish you many successes. Now we are going to go to Paul, and then we will have question answer session. I'm leaving now with in good hands of Ali. And I hope you enjoyed the presentation.
Thank you, Suleyman, for the fruitful presentation. Dear audiences, I am going now to launch a poll for the question of the Suleyman. Are you ready to embark this journey? Yes, not sure, or no? You can start now. Please choose your answer, and I hope it will be yes. And if it's not yes, please make your plan and make it yes. So Suleyman, I think the audience are willing to go on this journey. So we have like 85% of them who answered yes.
Very good, very good.
Yeah. Now I will
can
open
tell
the
you,
floor.
I've been in this industry for 46 years, and I've loved every moment, and even that in retirement, I'm still connected to the industry. Then I hope the same thing will happen with you guys.
Yeah, thank you, Suleyman. Now I will open the floor for the questions. So if you go on your right, you will find a question tab where you can write your questions. I hope everybody can see it. On your right hand side, there is a tab of questions. So you can put your question there. So Suleyman, let me start with the first question. So you spoke about being ready for the market demand, right? So what skills that new generation should have in order to be ready for this market demand?
First of all, you need to be able to understand the refining and the past market. What was the past market? What was in the 60s, 70s, 80s? To see the evolution of the market and recognize what the future looks like, either environmental restrictions, product specification, or alternative fuel, transportation fuels, for example. But the best way to learn while you are still a young engineer is to read a lot of documents either in the internet or attend conferences and read the papers. The expertise of knowing the market takes time to for a young engineer to realize that, but there are expertise out there who publishes paper, consultant who publishes papers, and through that you will know what the market will look like. My recommendation is to be able to read the magazines, the relevant magazines, and if possible, attend conferences or get copies of the paper from the conferences to understand the market. But to be always linked to the industry. Because you are an engineer of a certain equipment doesn't mean that all day you have to work on that. Spend every day an hour looking to the internet about what's happening in the industry. LinkedIn has a lot of good information. And also those two conferences in the Middle East, there is at least a conference every 2 months. Sometimes you are not being able to attend this conference. But as a student, I know there's a lot of advantage because you don't have to pay, especially the people who are close to Bahrain. There's a lot of conference in Bahrain. But understand the market. Understand the market is to read, to attend, to ask questions, or even if you have a department, planning department or market department, go and talk to them. Get an appointment with them and have them mentor you on that topic.
Sure. So we have a question from Mohammed Al-Qahtani, I think his name. So he's saying, what is the difficulties you face in your work in refineries? I hope you can see the question.
The difficult, I mean, one thing I didn't mention too much, but safety has been always a key parameter in the refineries. The first thing, you need to operate safely. The safety rules are crucial, and you have to understand as an engineer what are the safety rules. That's normal. It's like, can I have a human who doesn't breathe? The breathing for you in refining, the challenge is to be able to be working in a safe environment. The other challenge is it's costly to make changes. If suddenly your refinery has 32% fuel oil and you want to reduce it to 5% because you don't have any more a market to invest, you need $1 billion sometimes. There's a project in the region that upgraded their refinery for resid conversion. They spent $2.3 billion. And the other challenges, of course, is sometimes having the right talents. In the West, especially, we see a lot of experienced operators retiring, and getting new ones experienced ones are not easy.
Yeah. Thank you. So there is another question by Nadia Haji. So she's saying,
Oh yeah, I should stand up then.
yeah.
She's
So
the expert. How can I ask me questions?
I don't know, but she did. So she's asking, how can we bridge the gap between refining and petrochemical? I think there is a huge project in Kuwait, BIC. So I think they are integrating now refineries with the petrochemical. So she's asking how we can bridge this gap.
I mean, it's a very interesting question because in the past, we used to have refinery by itself, petrochemical by itself. The people in refining will run a certain way, the petrochemical will run a certain way. And their philosophy were very different. Now these days, more and more projects are integrated, which means refinery and petrochemical are integrated. Then there's periods where there's a transfer pricing of product going from one to the other one, and there will be a competition. You give the refinery a performance to deliver financial, and the petrochemical. The success is when the two is not anymore two different companies, but it's one company. There's one person in charge who takes crude oil and makes products, either transportation, fuel, and petrochemicals. But if you can come with the philosophy where you operate refineries and petrochemicals together as one, that's fantastic. In Turkey, there's an example. There's a Star refinery in the near Izmir, and petrochemical Petchem. Now they are going to integrate. Even some of their divisions are going to integrate. But it's integrating these two companies is a must in order to work well. But not to have two competitive companies, one refining and the philosophy are very different.
Yeah. Thank you, Suleyman, for answering this question. So you spoke about hydrogen, and I believe you have a lot of papers around hydrogen. So we have a question from Shakil Ahmed. He's saying, how do you see hydrogen as a new fuel for future?
In 1976, I had a lot of hope. This is what? This is more than 40 years ago. And there where we had possibility to get nuclear energy and other energies to make to take water and convert it to hydrogen. It's becoming popular. The question is, will it be economical? That's the big struggle we are having. With oil price at $10, $20, hydrogen is not very competitive. We had even a World Hydrogen Energy Association in the 70s. The association is still existing, but and then even there were universities that their buses were using liquid hydrogen for their car. It's going to take some time. It's like electrification of car. Hydrogen will take its time, but Shell and other companies are in it. But the question is the cost, or is it because it doesn't pollute the air and it's a clean fuel that is more attractive? But the cost wise, it has to be competitive in order for hydrogen to become more popular. But there will be niche market for hydrogen, that is sure.
Actually the cost and because of the environment, I think it's more clean than
Yeah,
the
what you
gasoline.
pollute, what you do
Yeah.
is water. But if it is what to produce hydrogen, you need electricity, per example, or you need again hydrocarbons to produce hydrogen. Still, you are going to be involved in pollution, unless you go nuclear. Nuclear is another issue.
Yeah.
But the people who are in this hydrogen business has to convince us that it's competitive and it's very good for environment. And many papers that are written talks about it's good for the environment. But we are, I mean, if I waited 40 plus years to see this attractiveness, will it be another 10, 20 years before it becomes other? But it's a niche market. I see an interest in Australia. I see interest in Germany. But it's a niche market.
Okay, so you mentioned also about the methanol, I think.
Yes.
So what about methanol?
Now
So
methanol,
what happened now for methanol?
the methanol has the health issues in using in gasoline because you don't want to be contaminating your eyes, your body with methanol. Methanol was popular many years ago, but these days methanol for transportation fuel not, but for petrochemical, yes. I know a project in China that produces ethylene and propylene from methanol, and ethylene goes to ethylene oxide and propylene goes to polypropylene. Then there will be a space. And the nice advantage of methanol since the beginning is when you have natural gas in your country, but no petrochemical near it, and you want to build a petrochemical far away, you transform the methane into methanol, transform methanol as a liquid, and then build a petrochemical somewhere else. That was the attractiveness many years. But the economics were not very good for many, many years. MTO was available in early 90s for licensing, but then it became popular in the last 5, 10 years. UP is leading this activity, and there's also Chinese technology. Methanol for producing olefin, yes. And the beauty of it is that you can selectively play with it to make more propylene versus ethylene. But it's in a nice alternative way to produce olefins.
We have another question, this time from Ali, the one you have asked about. Another Ali.
Oh, my Ali, yes, the
Yes,
one who volunteers, who is volunteering for the Kobe, for the Wuhan virus program in Bahrain.
exactly.
I am very
So
proud
he,
of you, Ali, for all these pictures you send of fighting and disinfecting shopping centers, etc. Very well done.
so so he's saying, with your great experience, what do you think about the future of downstream industry, considering the current tense situation?
The current situation, first of all, let's forget about the current situation. The current situation will be resolved. If it doesn't resolve in 4 months' time, it's going to be resolved when we will have immunization, etc., in 1 year. Then this is a period where we are all closed and we are recharging the world again. Once we come back of this nightmare, the industry will have to adapt to the things I mentioned: petrochemical, uh, cleaner fuels, CO2 emission, and all these things. And the refining industry will continue to flourish. There are 700 plus refineries in the world, an average utilization rate of 85%. Small ones will have to be shut down maybe if they are not in a niche market. Big refineries, big complex will be made. and refineries no less than 300,000 barrels a day will be built. But key again, remember the thing I said, average age of the best refinery is 26 years old. There's a lot of things you can give me any refineries in the world, and I can, with certain ideas, improve it further and make it more competitive. But the key now is going to be fuel oil. Refineries are not going to be a machine to make fuel oil anymore, unless there's a need for power plants or need for marine fuels.
Okay, so I think we will have the last question now.
Okay.
So what is your advice to start our career? Right. What about motivating youth in the industry?
I mean,
So
I
it
hope
is actually,
I
let
hope
me rephrase it. Yeah, so let me rephrase it. So what's your recommendation for the juniors who's going to start their careers just now?
Okay, first of all, as you can see, I'm here 69 years old, still passionate about this industry. And the journey I went, there were never a boring time. Now you're coming to the industry out of your universities with very talented academician professors have supported you, and the industry have supported you, wanting you to come to the industry. My biggest recommendation, if you are a technical, you are an engineer, please work at least 10 years in engineering production, but engineering work before you want to be a manager running businesses, doing economics, doing market planning. But at least 10 years be technical. Do not come to the industry and work 3 years as a technical person and then decides to go to a managerial positions or doing business running jobs or marketing jobs or sales jobs. It is pity. Your parents, yourself, you have sacrificed so many years of your education to become an engineer. But once you become a good engineer, then there's many opportunities where you can go. You can go planning, marketing, operation, research, R&D. And some of you, please come to R&D. Be involved in R&D, especially in your countries in Saudi Arabia. There's a lot of money invested in R&D. There's a lot of potential to work in R&D and a lot of good things to do. Digitalization is very popular these days, but I will tell you, there's nothing boring in the refining industry. But one thing, if you want to stay in downstream industry, at least work 2-3 years in a refinery before you go to an office job. But know how to run a refinery. Do startups. Be involved in projects. Projects can be very attractive. You know, suddenly your company, let's say Aramco, Sabic, Babco, are investing multi-billion dollars in a project. Be in that project and deliver with the team. You will learn a lot. You know, don't learn to play tennis looking to the internet. Go and play tennis on the court. It's the same thing in refining. Don't learn refining on the internet. Go and learn on the field by playing there.
So Suleyman, we have one guy. He's Abdulaziz. He's insisting to ask you one more question,
With
and
pleasure.
I will turn on the voice for him. He's from Kuwait KMBC.
Okay,
Yes,
very good.
Abdulaziz.
Okay.
Abdulaziz, yes, you can go ahead.
Hi, Abdulaziz.
Abdulaziz, unmute yourself.
Hello, everybody.
Yes, Abdulaziz. Yes,
yeah.
We can hear you.
Okay, I'm Abdulaziz from KNPC company from Kuwait. Thank you for your the rich presentation. I believe we need more of these presentations to cover your rich journey, Mr. Suleyman. My question is regarding, you mentioned solar energy and the refinery. And you know that the refinery is, especially here in Gulf countries or Gulf, in the Gulf countries, is core of their economics, or refinery or oil and gas sectors, the core of their economics or their business. So adding solar energy to the refinery, do you think it's kind of contradiction to have a solar energy instead of the refinery products, which are using to generate energy for motor engines or the power plants? So it's kind of weakness to have a solar energy in the refinery.
You know, this question has been posed in another conference. Someone said, you guys are lucky in the Middle East. You have plenty of sun and plenty of oil, which means now you have to decide when to use which one. Solar will have some niche application. For example, equipment that are on your pipeline in the middle of desert where you don't have a power structure there, but you can use solar panels, for example. There is niche market. It's not competing against your high crude oil based products, but it's going to be a niche market. There is a need for, in certain niche application, you can use solar panels. Why not? And it's less pollutant, but again, the cost has to be attractive. If the cost of your gas and your fuel oil is so cheap, no one will invest in solar panels. But if there is certain niche application, yes, they will use it. But again, you are lucky to have both of them, and you are lucky to choose which one you want.
Okay, I think by this we ended our Q&A. I would like to thank you again, Mr. Suleyman. Also, I would like to thank the audience. So thank you for this amazing session, for your amazing, let's say, presentation. And till you see you again, so goodbye and be safe. Thank you.
Thanks, everyone, and I wish everyone a lot of successes. And don't worry about the crisis we are going in. It will be resolved because we have good researchers, good doctors. Everyone is going to work on it. And be safe, be good, take care of your parents, take care of the older people. Thank you.
Thank you very much, Mr. Suleyman. And for everybody, the session is recorded, and it will be available for anyone who missed it or he want to just check it again. There were many questions. Sorry if the time did not allow us to ask all these questions. And hopefully we will see you soon. Stay safe, Mr. Suleyman.
Thank you.
I want to thank again BChemE, all the people in the BChemE, and represented by Ali Isa, AICHE chapter from KFUPM, represented by Abdurrahman Lahmari. They did great job. So looking forward for more and more of these helpful session during this curfew time. So I think we have a lot of time to have many of these sessions, inshallah. Thank you, everybody.
Thank you, everybody. Till we see you on the next session of LIT series webinar. Thank you and goodbye.
Thank you. Bye.